Welcome back, everyone. I hope you guys are rested, had a little bit of a tea break or whatever you want to do. So up next, we've got a wonderful lightning talk about pitfalls of infrastructure as code. I hope y'all are ready for Tim Davis. If not, remember the code of conduct. But before that, he's got a little joke for us. Do you have a joke, Tim?
Well, I did not come prepared for this, of course, but the joke, obviously, I'm from Texas, so let's just assume that I rode my horse to get here.
We have elephants roaming because I'm in Africa. But anyway, no, I'm just kidding. I just wanted to put you on the spot a little. I am
Absolutely.
excited and looking forward to hearing your talk. And yeah, take it away, please.
Awesome. Well, thanks y'all so much for having me. I'm really excited to be here. I really wish that we could do this in person. Obviously, it would be a lot better that way. So hopefully next time we can all be together for this. As mentioned, I'm going to be talking about a little bit of the pitfalls of infrastructure as code and how to avoid them. Right now, I'm a DevOps advocate for an infrastructure as code automation startup. Before that, I was with VMware doing a few things like cloud developer advocacy, pre-sale systems engineering for networking and security. Before that, I was an enterprise architect and infrastructure as operations. Long story short, I bring the ops to DevOps. I come from the operations and infrastructure side of the house. But really with all that, I've always been focused on the application because there really is no point in delivering infrastructure just for infrastructure. You're delivering it for the sake of the application that runs the business. So that's kind of why I'm here talking to you today. So what is infrastructure as code? Luckily, the name kind of has everything in it. It is infrastructure and it is code. Back in my day when I started, infrastructure was racking and stacking physical servers, cabling, doing things that needed to be done, installing stuff. It was all very physical, manual labor. I cannot count the amount of physical servers that I have unboxed and racked. It is in the hundreds to thousands. It's ridiculous. But with the advent of automation and public clouds and things like that, infrastructure became different. It's not just physically building stuff. You're going into a user interface. You're clicking around and kind of building and saying, I need an EC2 instance with an RDS and connecting them together. And all of it's very graphical. Well, with that and the speed that came along with that, developers started going through and deploying their own infrastructure. Sometimes if they were allowed to, sometimes when they weren't, it is what it is. Just trying to do their jobs as fast as they can. Well, developers don't necessarily want to click around in UIs and do what they want. They want to do what they always do and package code and deploy it that way. And that's really what brought around the infrastructure as code model. So what are some of the pitfalls that can come up with infrastructure as code? I've got good news and bad news for you. The bad news is that it's a lot. It's all of the pitfalls that come along with infrastructure and all the pitfalls that come along with code. It really comes with all of that. But the good news is you basically already have the tools to mitigate a lot of this as it is. You have an infrastructure team for the most part that knows what they're doing. They've been doing infrastructure for a long time. You have a development team probably that's coming together. So why not bring those groups together? The very first pitfall is just not having the communication that you need to, do this. And you just kind of try to do it. You may fail a little bit. You may have problems. If you just bring these teams together, foster that communication, then you can take the wealth of experience that everybody has to be successful. And it's not just dev and ops. It's networking and storage. It's all of these security, all of these different teams. If you bring them together, then everybody can have a lot better time overall. So let's talk about some infrastructure pitfalls. First thing is, like I said, making sure that you have that communication. But the very first and biggest options out there, the de facto industry standard at this point is Terraform. Pulumi is catching a lot of ground these days. There's a lot of pros and cons for everything. But one of the big splits in these is either cloud agnostic or a multi-cloud framework or a cloud specific framework. If you're all in 100% on AWS, most likely you are either using CloudFormation already or are thinking about using CloudFormation. That's great. But what if your company is acquired or you acquire another company that uses another cloud? You can't take that CloudFormation and deploy it out to Azure. If you're using a cloud agnostic or cloud, multi-cloud framework like a Terraform, Pulumi, or a TerraGrunt, you can, of course, take that and just deploy it out to Azure, but you're going to have a lot better time of having that framework that can support those multiple clouds, multiple platforms, so that you have a better starting point. So it may be a little better for you if you choose that multi-cloud or cloud agnostic framework. Long story short, I can't tell you which one to select because the engineering answer is it depends. But definitely take your time, weigh your options, and make sure that you take this very first step lightly and that you select the best framework for you. Security. I mentioned it a little, just a little bit ago here about making sure that it's not an afterthought. Security has to be involved in the conversation. When you start doing infrastructure as code, you start automating, you need to make sure that you're bringing them in. Shifting security left, bringing that closer into the deployment process. Instead of deploying stuff out there and waiting to get yelled at by security, use tools like Terrascan or Checkov to make sure that everything is secure before you deploy it or during the development process. That can help you save time. And instead of taking 5 steps back when something's broken or not working, you can solve that problem, with that and just take 1 step back, fix it, and then move on quickly. So what about some of the code pitfalls that you may run into? Default values. If you've ever deployed something in AWS or Azure or Google, you know that that UI has a lot of different boxes. Like if you click to select an EC2 instance to deploy, there's a lot of stuff that you have to fill in. What's the name? What VPC is it connected to? What are some of the IAM policies? Well, what happens if you don't put something in one of these boxes? What happens if you select the wrong one? When you're doing it in the UI, it's pretty easy and it gives you little errors and it tells you what you need to do. If you're designing code for this, you have to really know all that stuff while you're designing the code and while you're building that out. Otherwise, it could fail on deployment until you need a value for something that you didn't specify, or there could be a default value selected. Like if there's a default IAM policy that's not quite secure enough, then you need to make sure that you're going through and selecting the right one. So always making sure that you're designing that code properly can always help you out and make sure you're doing that correctly. What happens when you leave it blank? All of these things you need to solve for during the development process. And these keep falling onto my face. So we're just going to change it up and we're going to put them on the face here. So how do we mitigate value issues? So Open Policy Agent can absolutely help you with that. It can help you design your code in such a way where not only can you enforce saying we have to have specific values like how many nodes in a Kubernetes cluster or which region are you allowed to deploy to. It can also help make sure that you don't deploy something that's missing certain values that you may need to specify there. Dry, don't repeat yourself. This is a common development methodology of simply designing smaller, more manageable, more repeatable code. So this can come along with a lot of issues where in infrastructure as code, if you have 5 different environments like development, production, and what have you, you could have 5 different copies of the same code with all of those values just kind of hard coded in there. So how do we mitigate some of these issues? Things like Terragrunt and Terraform modules can help you break that code up into more manageable pieces. And then also using the dry methodology, instead of hard coding those values, just inject them as variable values. That way you only have one base set of code that you have to manage. And then each deployment just gets its own variable values or, inputs that you need for that. Designing for state size. When you deploy stuff with infrastructure as code, you end up with a state file. It has every single thing that was deployed, all the configuration, and all of that. If you have a giant state file, it can make your deployment processes take quite some time. So how do we mitigate state size issues and help speed up that deployment performance? The good news is we literally just learned that. The dry methodology that we just talked about. If you break your code up into those modules or use Terragrunt or something, not only is it going to give you more manageable, less code for updates and things like that for designing your code, it's also going to help that development performance along the way. So that say when you need to add an extra EC2 instance in there, it's not going to have to go through and validate all of your VPC stuff, all of your RDS stuff, all of your, everything else. It's just going to check that one module and redeploy. Then, of course, you can set up your automation to kind of chain that through and allow you to redeploy any prerequisites or post-requisites or anything that you may need to do. So overall, the overarching message for this last part here when designing code is it will always help you out if you break that up into smaller, more manageable pieces so that you don't have one giant file that has one giant state file and you have multiple copies that you have to update every time there's a change. Just making sure that you're using those development methodologies, you're breaking stuff up. It'll help you, for a more manageable going forward when it comes to deploying and managing your code. So if you want to learn more, there's Q&A and stuff here. The fastest way to get me is, of course, on Twitter at VTimD. Feel free to ask any questions or anything like that. There are a ton of great people out there in the community to help you. There's lots of great resources to get started with infrastructure as code and automation. Hopefully this quick talk, got you some helpful information and stuff like that. And, like I said, I hope to see you in person next year.
All right. Great. Thank you, Tim. That was
Absolutely.
great. Yeah, it was awesome. It was not only pitfalls, it was just like best practices.
Exactly right. And I really hate the term best practices, because when it comes to architecture and stuff, just because it's good for 90% of folks doesn't mean that answer may be the right person for everybody. Yeah. But it's just one of those things where sometimes if you make sure and you kind of think everything through, it can always help you out in kind of weighing all those pros and cons across all of your decisions.
Of course. And that you can stress enough that don't repeat yourself thing. And that applies to everything we do. I think modules
exactly
is the right approach.
Smaller, more manageable pieces can help you out in so many different areas. I mean, performance of deployments, manageability and everything. So that's definitely a great
and
way.
Also for easier to share with the community and take from the community.
Exactly also. Right. Take that module and share it out, because once you have all of your values and stuff extracted from it, it's sanitized. So technically you can share that code for anybody who might need it.
Exactly. Well, thank you. I loved your talk. It was great.
Thank you.
We don't have any questions from the audience. I don't have either. I think it was great. So I appreciate. Thank you again. We'll see you in Twitter probably.
Sounds great. Thank you all so much.